Okay, here's the video for 4.3 continued. So I labeled 4.3b, and we're going to simplify complex rational expressions. I crossed those out. I asked you to wait for a little bit to solve those, but now we should be able to solve them. It's the problems on your worksheet 4.3, and I picked a few of them for us to work on. So I'm going to do the letter A, and then we're going to do letter C, and then we'll do a few more. There's not very many of these questions. These are called complex rational expressions. As you can see, it looks pretty complex, right? You have a whole number plus a fraction as a numerator, and then you have a variable plus another rational variable here as a denominator. So this is called a complex rational expression. The way to tackle those is to clear the denominator. We really would like to clear these fractions, the denominators on each of these fractions. So to be able to do that, we need to find what is called the least common denominator between all of the denominators. So why don't we list all the denominators we have here? A number 1 can be written 1 over 1, and the x variable can also be written as over 1. Every whole number can be written as a rational number, as a fraction. So there we go. I have all the denominators that I would like to get rid of. And the 1 really doesn't make a whole lot of difference. And then we have the y. I don't know what y is. Y could be a 3, could be a 10, could be a 15. I really don't know what y is. But anything between 1 and y, the least common multiple of these two values would be y. Okay, so the least common denominator would be y. If I multiply all of these fractions, each of one by the y, I'm going to multiply this one by y, this one by y as well. I'm going to multiply this one by the y, and this one by the y, because that is the least common multiple of all of these denominators. Then I can go ahead and clear the denominators for every single one of these fractions. So here, I really can't clear this denominator, but it's just a 1. So I would have a 1 times a y, which would be a y. Plus, here I know I can reduce this because they're common factors. So I would just have a 1. All over, here there's a 1, so I really can ignore it, and I have x times y. Plus, and here the y's would cancel, and I would just have an x. So there you go. I went from a really complex fraction, I cleared the denominator, and I end up with a numerator over a denominator. Now our goal is to factor. If we can, we factor some more, and then we reduce if we can. Just like every single fraction, we factor and reduce. So as I can see here, there's nothing I can do with this binomial. I'm going to group them because I like to see that as a group. Here, I know that this first term and the second term has x in common. I'm going to factor out this x. I'm going to write the numerator again, y plus 1, all over. I'm going to factor out the x, and I'm going to have a y, because if I divide an xy over an x, divided by an x, I get a y. Plus, if I divide an x by an x, I get a 1. So there you go. I factored completely, and I'm going to reduce common denominators. I see that this is 1 times y plus 1, okay? So once I reduce this, I have a common factor on the top and on the bottom here. I can reduce it. We end up with the answer being 1 over x. And that is our final answer, reduced. This is actually what this ginormous complex rational is, okay? It was really funny looking at the beginning, really difficult and complex. We reduced it, and we became this right here, okay? All right, so let's do another one. Let's do letter C. As you can see here, letter C, let's go ahead and list all the denominators that we would like to get rid of. Okay, if we didn't have these denominators, it would be a really simple fraction. So I'm going to list, I have 7x, I have a 14, I have a 14x, and we have a 7. Okay, so we have all these denominators right here. I'm going to label denominators. Okay, I have all these denominators right here. Between 7 and 14, I know the common multiple between is a 14. Okay, between 7 and 14, The multiple of 7 is 14, and there we go. And then we have this x that we would like to get rid of. So I'm going to call it the least common multiple between all of them would be 14x. I know 14x is divisible by 7x. I know 14x is divisible by 4. I know 14x is divisible by 14x. And I know that 14x is divisible by 7. So I checked, I know that it works. Okay, 14x is divisible by all of them. I'm going to use 14x to multiply every single one of these fractions by 14x. Okay, I'm going to multiply by 14x here. I'm going to multiply by 14x here, also by 14x here, and also by 14x here. I'm not going to shortcut because I don't want anyone to get confused. So let's take care of one fraction at a time. And I'm going to rewrite it right here. This first fraction right here, I can reduce the x's. They are common factors. And I can also reduce the 14 divided by 7, which is a 2. And then we have this 2 times this 2, which becomes a 4. Minus, now let's go over here. We can definitely reduce the 14s. They're common factors. And the only thing I have left over is a 3 times an x. So we get 3x. Okay? Whatever is left over, the factors that could not be reduced, we multiply it. Because that's what we're doing here. We're multiplying them. Okay? All right, here we have 14x times 3 over 14x. Immediately you see that these two are common factors. So I'm going to reduce it, and we're going to get a 3. Minus, because that's the minus we had here. I know that 7 and 14 can be reduced, and we end up getting a 2 over here. So now I have a 1 times a 2 times an x, or 1 times 2x, which is 2x. Okay? And I cleared all those denominators. I look here, and I say, well, between 4 minus 3x, there is no common factor. This is a group. As you can see, if you forget about the denominator, there's really nothing you can factor out between a 4 and a negative 3x. Okay? If you look at the denominator, there's really nothing in common between a 3 and a 2x. There's nothing you can factor out of both of them. Therefore, these are already reduced. A lot of the students have this temptation, this crazy temptation of reducing this 3 with this 3 and this 4 with this 2 and canceling out x's. It's just a bunch of illegal moves that you're making here. This is a grouping. In order to reduce something, we would have to factor it. As you can see, I always write factor and reduce. So it always should be factor and then reduce. Well, there's nothing that can be factored out, so I cannot reduce. Okay? So I am done. This is my answer. All right? Let's try one more time to make sure we understand how to do this. I have letter D here. I could do this in a different way. There is a different way to solve this, and some students see it. But I am going to keep the same process so it makes it easy on everybody. I can see a m over 1. I can see a 7. I can see a m squared over 1 and a 49. So I'm going to list all my denominators here. Denominators. I have a 1, I have a 7, and I have a 49. The least common denominator of all of these values is 49. I know I can divide all of these. 49 is divisible by 1, 49 is divisible by 7, and 49 is divisible by 49. So it works. My least common denominator will be a 49. I'm going to multiply every single value over here by 49, by 49, by 49, and by 49. Okay? So when I multiply this by 49 over here, I get a 49m. Plus, over here we can reduce the 49 and the 7, and we get a plus 7. There we go. Then on the bottom we see that nothing reduces here. We get 49m squared. And here the 49's reduces, and we get a minus a 1. Okay? All right, now we are ready to always, as I say, factor and then reduce. Okay? We cannot reduce until we factor it because we have a group here. We have a group, we have a binomial of two terms here. Okay, so if I look at the numerator, I have a 7 and a 49. They're both divisible by 7. I'm going to factor that out. And I get a m plus 1. Okay? And then on the denominator, there's really nothing in common between a 49m squared and a 1, but you should be able to see that this is a 7 times 7. That's an m times m. So this is a difference of squares. A number 1 is always considered a squared number, can be considered a cubed number, can be considered anything. Number 1 is very special. So I have a difference of squares here. This is 7m plus 1, and is also 7m minus 1. I made a mistake here. I just realized it. 49m divided by 7 is 7m. There we go. I knew I would catch my mistake as soon as I see the denominator. Okay? So as you can see, the denominator and the numerator have a factor in common. That's why we factored. So I can go ahead and reduce my 7m plus 1 and my 7m plus 1, and there we go. Okay? We end up with 7 all over 7m minus 1. This is a group. Keep them together. There we go. So here is an answer. Some students, let me give you a heads up, some students have a similar answer to this because they saw from the beginning that this question was a difference of squares. Okay? And I'm okay with that. There is a different answer, which it would be 1 over m minus 1 over 7. Okay? It's kind of like if I divide everything here by a 7. This is also another option of answer. They're both okay. I'm okay with either way. Okay? All right. Let's do this one last time. Let's take a look at the denominators that we have here, because that's what we want to get rid of. I like to see my 1s here, even though it doesn't make a whole lot of, doesn't make any difference. Okay, so we have the 1, the denominators are, we have a 1, we have an x squared, and we have an x. The least common multiple, the least common denominator multiple that I'm going to use for all this is an x squared. Because I know that x squared can be divisible by 7, by x, and an x squared is also divisible by x squared and is also divisible by 1. It works. So I'm going to multiply every single one of them by an x squared, and by an x squared, and by an x squared, and by an x squared. All right, now let's go ahead and start clearing up these denominators. Remember, we have a subtraction in the numerator and a subtraction in the denominator. Okay, here, nothing reduces. We have 1 times x squared, which is x squared. Here, the x squares reduces. Because they're common factors, we get a minus 9. Look at this beautiful difference of squares that just showed up. Okay? Here we have a 2 times x squared. And here, one of the x's reduces with one of these x's over here. We end up with minus 6x. All right. I cannot reduce x's with x's, 2's with 9's with 6's. Stop thinking that. This is a group, it's a binomial, and this is another group. We must factor, and then we are allowed to reduce. Okay, put that in your minds. We must factor it first. So here I see a difference of squares. X minus 3 times the quantity of x plus 3. All over, I do see that this is divisible by 2x, and this is also divisible by 2x. So I'm going to factor out the 2x. And when I divide this 2x squared by 2x, we get an x left over, minus 6x divided by 2x is a 3. How nice. They have a common factor on the numerator and denominator. Because we factor it, we were able to find the common factor, which is the x minus 3. We may reduce those common factors, and we end up with the numerator of the quantity of x plus 3 divided by 2x. Okay? We are not allowed to reduce x's times x's here. We already did all the reduction that was needed on the top here of common factors. We are done. Okay? And that is it. As you can see, we're always looking for the denominators and the common multiple of all these denominators so we can create our least common denominator. Okay? And that is how you do for this section 4.3. Good luck.